Lesson 19, the workbook, we're going to jump down to question 10. Alright, circle C lies on the coordinate plane with its center at 9, -7. The radius of the circle is the square root of 34 units. Without graphing the circle, Claudia writes a paragraph proof to prove that point P, 12, -2, lies in the interior of circle C, but she is missing a few steps. Read her proof carefully, then follow the instructions. Okay, since all points on circle C are at the same distance from the center, use the blank to see if the point is inside the circle. Okay, I would say use the radius since the radius is the same distance from the center. So blank 1, I'm looking for a radius, but I'm not seeing radius. So then let's read the next sentence to see if we have a hint. Then substitute the x and y coordinates to obtain blank. The distance is blank. This distance is blank, the length of the radius, which proves that point P is blank. Match each numbered blank to the answer that correctly satisfies the corresponding blank in the proof. Okay, so sorry, that was probably loud. Claudia writes paragraph proof to prove that point 12, -2, so is blank 1 the distance formula? Since we would use the distance formula in order to find the distance to determine if that point is inside the circle. Then substitute the x and y coordinates to obtain. So what is the distance formula? Well, the distance formula is going to equal the square root of our horizontal distance, so x minus x1 squared, plus our vertical distance squared, so y minus y1 squared. Okay, so now it is saying to substitute the x and y coordinates to obtain. Alright, well, we have a center, so I'm going to say D is equal to the square root. Our center, I'm going to say is x1, so center x coordinate is 9 squared plus, so it's y1, so that'd be minus a -7, and this double negative, this first subtraction sign comes from just the distance formula, and that's being squared. So then what are the other x and y's that we have? Well, we have the point 2 and -2. So this now is 12 is going to be in our x coordinate value, and -2 is going to be in our y spot. So that distance is going to equal the square root of 12 minus 9 squared plus -2 minus a -7, that becomes plus 7 squared. Okay, so now let's see if we have any of that. 9 minus 12 plus 7 plus 2, or 9 minus 12 plus -7 plus 2. Well, it seems like they used the x and y's differently. So if we went back and we switched all of these that we wrote, we would have a 9 minus a 12 squared plus -7 minus a -2. So if we switched those, just basing off of what they did here and here, which is completely legal as long as you switch both of them. the x and the y values. So we're switching those. So then we would have the distance is equal to the square root of 9 minus 12 squared plus negative 7 plus 2 squared. So then I'm looking, and that one is what matches, so blank 2 is going to be that. The distance is blank. Okay, so what is the distance? So D is going to equal the square root of 9 minus 12 is a negative 3 squared plus negative 7 plus 2 is a negative 5 being squared. Negative 3 squared is 9 plus negative 5 squared is 25. So the distance is equal to the square root of 9 plus 25, which is 34. So I'm looking for a distance of 34, the square root of 34. So blank 3 is the square root of 34. And then this distance is blank the length of the radius. So we are comparing it to the radius. So the radius is square root of 34 units. Well, it's the same as, so it is equal to, and which proves that point P, well, since the radius is the square root of 34 and the distance from the center to our point is the same as the radius, that means it is not in the interior of the circle. So it is not in the interior, it is on the circle. So it is not in the interior of the circle. So we're going to submit that for grading. Great job. All right. So there is question 10. Question 9. All right. Circle K has the equation x plus 2 being squared plus y minus 1 being squared, which equals 9. Ashton writes a paragraph proof to prove whether point A, negative 1, 4, lies in the exterior of the circle, but he is missing some information. So when you're trying to prove whether or not it's on the exterior of the circle, you want the distance from your center of your circle to your point to be bigger than your radius. So your radius would stop here. So if you can prove that the distance to your point is greater than your radius, then you can say it's on the outside. So that's just how I would visualize it in my head. Let's read his proof and follow his instructions. So it is given that the equation circle K is x plus 2 squared plus y minus 1 squared equals 9. This means that the center is blank. Okay. Well, I'm remembering back to the equation of the center of a circle, and it's x minus h squared plus y minus k squared. And that equals r squared. So our center is right here. And since this 2 is positive, I know that since in the generic equation there's a negative there, that this had to be a minus a negative 2 in order to become a positive. So I know that my center point is going to be negative 2, 1. Because that negative sign that is right there, you see, is built into the general equation. So blank 1 is the center of negative 2, 1. Okay, and the radius is, well, 9 has to equal r squared. So 9 equals r squared. So the inverse operation of a square is a square root. So what is the square root of 9? It is 3. 3 equals our radius. So our radius is equal to 3. If point A lies outside of circle K, then the distance KA must be blank the length of the radius. It has to be greater than. So blank 3 is greater than. All right. The distance formula results in the equation. All right. Well, I'm going to peer down here to see what coordinates they use first. And they use our center point first. So we have the distance between our center and the point is going to equal the square root of our horizontal distance. Our x coordinate for our center point is -2, and point A was at -1, so I know we have minus a -1 squared plus our vertical distance, so our y coordinate of our center minus the y coordinate of the point we want to check, so -4 squared. So we have KA is equal to the square root of -2 minus -1 is +1 being squared plus 1 minus 4 squared. Okay, so that is the distance formula. So blank 4 is our distance formula. So we are looking for the -2 plus 1 squared plus 1 minus 4. So blank 4 is right there. And it says evaluating the numbers in parentheses results in, okay, so evaluate the numbers in the parentheses. So KA is going to equal the square root of -2 plus 1 is a -1 squared plus 1 minus 4 is a -3 squared. So that is just evaluating the numbers inside the parentheses. So I'm looking for -1 squared plus -3 squared. And then evaluating the exponents and taking the square root results in. Okay, so we're going to evaluate the exponents and take the square root. So KA equals the square root of -1 squared is 1 plus -3 squared is 9. So 1 plus 9 is 10. And taking the square root of 10, square root of 10, 3.16. So KA is equal to 3.16. So blank 6. Okay, is the square root of 10. That's what we wrote. But he didn't take the square root yet. So that one, because the length of the radius is 3, or is because the blank of the radius is blank the distance of KA, so the radius is less than the distance of KA because KA is 3.16 and the radius was 3. So because it was less than it, point A lies in the exterior of the circle. So does or does not? It does, because that distance is bigger than my radius. So it does lie on the exterior. So let's check, make sure we have that correct. Great job. Okay, so now moving on to question 8. In the diagram, circle C lies on the coordinate plane with its center at C2, -2. The radius of the circle C is 4 units. Point P appears to lie on circle C at 6, -2. Amelia must prove that point P lies on the circle. What steps could Amelia take to carry out this proof? Does point P lie on the circle? Okay, so we just stepped through 2 of these proofs, so we should know. 1, you find the distance between the center and the assumed point you want to check. And then you compare that distance to the radius. So let's see if we can find what steps could Amelia take. So she can use the formula of the circle, x minus 6 squared plus y plus 2 squared equals 4. No, because she's not using the center points here. She can use the distance formula. CP is equal to 2 plus 6 squared plus 2 plus 2 squared to verify the length of CP is equal to the length of the radius. Yes, we want to find the lengths, but I'm looking here. We should have a subtraction sign because both of our x values are positive. So I know that one is not correct because the distance formula isn't correct. This one, she can use the formula of the circle and substitute the coordinates of P for x and y. If the resulting equation is true, then P must lie on the circle. That could also be an option. So that is true, and the reason why that is true is because if I were to plug in the points 6 and -2 here and simplify this out, I know that this is my radius squared, so it has to come out to be the same value in order to have the same radius. So that's one option. Or she can use the distance formula CP, 2 minus 6 squared plus -2 minus a -2 squared to verify that the length of CP is equal to the length of the radius. Yes, either one of those is a viable option. So I'm going to use the formula that they have, and let's just simplify that. So we have the square root of, well, I'll step through both of these to show why we can use either of them. So then 2 minus 6 is -4 squared plus 2 minus a -2, that is addition. So -2 plus 2 is 0. That's being squared. So then CP is equal to -4 squared is 16, and the square root of 16 is 4. So right there, that tells me that the distance from C to this point is 4 and our radius is 4. So that's checking for this one. Let's show you the other one. Okay, so they had the equation x minus 2 squared plus y plus 2 squared. They're using the equation of the circle. So they just plugged in that the center point was at -2, -2, and they plugged in the radius. So that's where this equation came from. It comes from the generic x minus h being squared plus y minus k being squared equals r squared. That's where it came from. So now substitute in the coordinates for p. Okay, well, p is 6 and -2. So we should have 6 minus 2 being squared plus -2 plus 2 being squared equals 16. So 6 minus 2 is 4. That being squared plus -2 plus 2 is 0. That being squared, that equals 16. So 4 squared is 16 plus 0 squared is 0. That equals 16. Does it, in fact? So 16 plus 0 is 16. 16 equals 16. Yes. So then It lies on that. It has to lie on the circle because this result, 16, that we found, only works when the radius is 4. That's the only way we would end up with a 16 on that side. So the radiuses would have to be the same. So yes, point P lies on the circle. Let's check to submit. Make sure we were doing this correct. Great job. All right, so now question 7. What is the equation of a circle with its center at -9, 10, and a radius of the square root of 3? Okay, well, our generic equation is x minus h squared plus y minus k squared equals r squared. Okay, so our center is our hk, and r is right there. So I'm going to substitute it in. H is -9. So I have x minus -9 squared plus y minus k, which is our 10, being squared, which equals our radius, the square root of 3, being squared. Okay, so x minus a -9, that is x plus 9 squared plus y minus 10 being squared. That's going to equal, well, the square root of 3 being squared is 3. So this is the this is the equation I'm looking for. So I'm going to look for an x plus 9. So x plus 9, that could be an option, plus y minus 10 squared equals 3. That is the exact one. So let's check it before we move on, make sure we didn't make a simple mistake. Great job. All right, so moving on to question 6. In the diagram, a circle lies on the coordinate plane. What is the equation of the circle? Okay, well, let's identify its center point, which is at -3, 3. And what is its radius? Well, let's count from anywhere it touches on one of these solid grid lines. I wouldn't want to find this because I can't count that. I can't count those. So that's why I'm going to find where it intersects on a solid grid line, because I can count that. So I can count 1, 2, 3, 4. The radius is 4. So then again, the equation of a circle is x minus h squared plus y minus k squared equals r squared. Okay, well, our h and our k are right here. We identified that and wrote down the coordinates. So then we have x minus -3 squared plus y minus 3 squared equals, our radius was 4 squared. Okay, so minus a -3 is a plus, so x plus 3 squared plus y minus 3 squared. That's going to equal 4 squared is 16. So there's our equation. So x plus 3 being squared plus y minus 3 being squared equals 16. So far they've both been the first ones. So let's check that, make sure we're doing that correctly. And we are. Great job. Okay, that equation, question 5 is exact same as question 6. So let's go on and answer question 4. A circle has the equation parentheses x minus 12 squared plus parentheses y plus 14 being squared equals 18. A, what is the center of the circle? And B, what is the radius? Okay, well, our center of our circle is located here. HK, how does this sign become a positive? It happens when we have a double negative, so it had to be like this first. And then So our k, hk, so our k has to be negative 14. And the h, since this sign is negative, that's how it is in the generic equation, so I know that that's 12. So there's our hk, so 12 negative 14. And then what is the radius of our circle? Well, our radius is, that value is r squared. So we have r squared is equal to 18. Now, this is r squared, not r. So the inverse of being squared is the square root. So square root of r squared is r is equal to the square root of 18. Now that doesn't look like anything that is given right here. They used the exact value, and thinking back to break down radicals, we factor out 18. So 18 is 9 and 2. 9 is 3 and 3. So I could rewrite this as r equals the square root of 3 times 3 times 2. All right, and square roots, you have to have two of the same value. So I can bust those 3 out. Hi, 1 second. So then I would have 3 square roots of 2. And so that's our exact value, 3 square roots of 2.